Alright, so I've had a few of you kind of ask me what are some of the components within our 12-volt soft wash pumps and how do they work, and then what are some of the reasons they fail. I guess some of you guys are having issues with your pumps and you're just wondering why you keep having the same repeat issues, or what are some of the repeat issues that if you haven't experienced it yet, you can kind of expect. So this specific pump is the Delavan 7870. This is the 7 gallon a minute at 60 psi model. They do make a 100 psi 7 gallon a minute model. There is not really any difference in these two pumps except for the settings on your pressure switch. So for your actual motor housing, this is where your brushes, all your associated wiring is going to be kept. You've got these large pole pieces or these magnets inside. We'll go over those here in a few minutes. For controlling the motor, you have your relay. Inside the motor, you have your armature setup and your commutator. This on the back is just a bearing. This piece on the front is your wobble plate bearing. It's supposed to be off-center. In front of that, you have your wobble plates and your check valves. All right, so we're going to get into this a little bit more in depth. All right, so for your relay, when you buy these in pumps, they should come with a relay. If they don't, you need to read that in the fine print. All of your relays should have a diagram on the side. So this little box with this line across it represents your coil. So terminals 85 and 86, or for real view, this bright silver terminal and this bright silver terminal. Those two terminals meet in the middle in a wire coil. That wire coil, when you put power through it, becomes magnetic. It's going to pull this rod and either open or close either one of these sets of contacts. So when that happens, this is controlling your motor. The switch on your control panel is controlling your relay. The reason we do this is because we do not want all of the current that is going to run through this motor to go through your switch. Your wiring and your switch are not built to, are not rated to handle that type of power. Your wobble plates and check valve assemblies. So these sit on the inside or the back side of your front cover. All right, so what happens is you have your inlet and your outlet. So when the wobble plate moves backwards, all right, meaning it kind of has a fully rotational, however offset axis, where one side of it is moving backwards, one side of it is moving forward, and it just kind of rolls in place. Whenever this moves backwards, what it's actually doing is this little rubber seal plate here is creating a cavity. It's sucking your fluid from your chemical tank in through this little check valve. You can take these little check valves and pull them out with your fingers. You see the vents under there. So fluid gets sucked in there. When the wobble plate then comes back around and compresses, it's going to push into the smaller or high pressure area. Now, I've already taken the check valves out of this because they were failed. They basically had a bunch of gunk built up in them, but they were completely torn up anyways. That's one of the two reasons this specific pump failed. So when that fluid gets pushed in through your high pressure check valves, it then goes through this little port where it passes the sensor for your pressure switch out to your hose. Now your pressure switches, you have 3 terminals. All right, and depending on the way this is wired up, this is either going to be normally open or normally closed. The way you adjust your pressure switch is this little hex head screw here. What you're doing when you turn this screw is you're adjusting spring tension on a little diaphragm that senses the pressure in your outlet port. Turning the screw in raises the pressure of the pressure setting of the switch. Rotating the screw out lowers the pressure. So, in a sense, you get more or less pressure at your actual hose or the end of your gun, but your pump is going to run longer. So it's a fine happy medium. Just keep in mind your pressure switches are built to run within a certain range. When you start playing around with them, you may get some funky readings, you may get erratic operation. Most of the time you're not going to burn your pump up, but you may actually break that spring on the back side of this. So just be careful adjusting your pressure switches. Make small increments, don't go crazy with it right off the bat. Now your housing. This is what houses your brushes, which have the ability to transfer the power from your battery onto the actual commutator here. Now each one of these slots on this commutator goes to a different winding. So depending on which winding you energize at any given point in time, you will create a magnetic field within this winding. When that occurs, the magnetic field you create within that winding will oppose one of these magnets. These being north, south, north, south. Now to illustrate what I mean by this, when we apply power to any given winding from our commutator and then it goes from there into our armature, what you're actually doing is you're creating miniature magnetic fields within this rotating assembly here. So to illustrate this, let's imagine that this one piece of wire, all this is a block of wood, 2 magnets, one piece of wire strung between 2 cotter pins. So this piece of wire is just free hanging, doesn't do anything. But let's imagine for a second that this is from your commutator in through your winding and then back out through the other side of your commutator. So I apply power here, that goes through, comes back around, up through the other side, and then onto basically the opposing side of the commutator. So then you end up with a positive and a negative. What you can do is, we all know that copper wire is not magnetic by itself. You have to pass a current through it. Depending on the direction that current flows, meaning positive to negative or negative to positive or vice versa, that will determine the direction of the current flow, hence determining the north and south orientations of your power or your magnetic field. So when I apply power to this wire, as you can see, a current flowing through that wire creates a magnetic field around it. This is coming from Faraday's law. So that magnetic field I'm creating around that wire is opposing or reacting against the already existing magnetic field with my magnets. This happens with absolutely everything that carries current, whether it's your vacuum cleaner cord or wiring in your car. The only problem is that with the insulation around the wire, most of that insulation is designed to counteract that, meaning you don't actually experience the effects of that magnetic field. However, in motors and generators, we don't use insulation. Now, some of the most common problems that we have out of 12-volt pumps are actually pretty simple to diagnose if you understand how your pump operates. Now, what I'm not talking about is, I'm not talking about tearing it apart and resoldering windings on your armatures or your commutators. All right, when it gets down to that far, just replace the pump. You've probably gotten your money's worth out of it anyways. What I'm talking about is simple things that you can fix on the site or fix on the spot. First off, if you have a motor that simply will not turn on, the first thing you want to check is to make sure that you're actually plugged into your battery, you're hooked up, everything's good to go. Do you have power coming through your switch? If you've got one of those illuminated switches, that's going to answer your question right off the bat. The next place that power is going to go is into your relay. All right, are you getting power into your relay? Is that contact closing? Are you sending that power to your pump? You can buy these relays at O'Reilly's and AutoZone. They're about 10 to 15 bucks. You just go in there and you tell them you need a 12 volt, basically a 40 amp rated or a 20 amp rated relay, whatever size you need for your pump. If you're running 2 pumps, you may need a larger one. Just tell them what you need, they're going to have it. If your pump will turn on, however, it has erratic cycling, meaning it's off, on, or it's pulsing, first thing to check is your pressure switch. All right, has your little hex head fallen out? Is your pressure switch leaking? Is there something wrong with it? Maybe tapping it with a screwdriver sometimes fixes it. You may have corrosion on the terminals. Pull the wires off, plug them back on. Otherwise, you're going to need to actually adjust the setting of your pressure switch. It's not hard to do, however, that hex head is very small. Most of us don't carry Allen wrenches that will fit that. If you do, sweet, good on you. The next and most likely reason that our pumps fail comes from two sources. The first is your check valve assembly. All right, if your pump is running but it's not providing any fluid, first make sure that all of your valves are open from your chemical tanks and you can actually get fluid to your pump. Check your filters, check whatever it is that is impeding that fluid from getting to your pump. If you know for a fact that you're getting fluid to your pump, however you're not getting any pressure out, from there you can diagnose it down to your check valves. Most likely your check valves have gunk built up in them. Now, other than forcing fluid backwards or forcing fluid forwards using another pump, there's really nothing you can do. Once you start tearing these pumps apart, you're going to start breaking screws. These are thread locked in at the factory. If you can actually get all these screws off and then put them back on without stripping or breaking any of them, I want to see it. Send me a picture of it. The next, if your pump won't turn on, or it's not providing very much power, or it's not a very smooth type running cycle, it may be early signs of your brushes wearing out. One of the things that caused this motor to fail was the check valves were bad. So I was starting to lose efficiency. I was starting to lose pressure and volume at the end of my hose. Once the pump finally gave out, the actual cause was these brushes in the back. The wires that are soldered onto them have broken off, and the brushes themselves have just worn down. Aside from fixing simple things, these pumps are not very maintenance friendly, so to speak. You're not going to tear them apart on the job site. You're going to have to bring them back to a workbench. However, keep in mind, for about 180 bucks to anywhere from 220 bucks, you can buy one of these, and they'll last you 6 months up to, as far as you can keep maintenance up on them. This specific pump has lasted me a little over a year. Part of the reason that I'm doing that is after every single job, not at the end of the day, just once, but after every single job, what I'll do is I'll close my chemical valve, open my water valve from my buffer tank, run clean water through this pump. What that's going to do is it's going to wash all that chemical residue out of your check valves and just clean your pump overall. A lot of guys say they won't do that until the very end of the day, and then they complain about these 12 volts pumps only lasting them 3, maybe 4 months. I'm not an expert, but that's probably why. These things have to be maintained. Yes, they are cheap in the grand scheme of how much our equipment costs. However, if you don't maintain them regularly as much as you use them, chances are they're not going to last you very much time at all. So those are some of the simple things that you guys can do to understand how your 12-volt pumps operate, some of the things that you can do to help fix them. If you need more help, if you have any questions, just like, subscribe, comment below. I'll do my best to answer them. See?